You know, our cars are talking to us all the time. Thing is, they speak this weird cryptic language of codes and mysterious lights. So today, we're going to learn how to translate one of those messages.
We've all been there, right? That little light pops up on the dash, and your heart skips a beat. Is it something simple, or is the car about to, completely give up on you? It's that universal moment of driver anxiety.
Well, in this explainer, we're putting on our detective hats. We are cracking a very specific case. We're going to follow the clues, we're going to interrogate the suspects, and we're going to solve the mystery of error code C1AEC. All right, so every investigation has to start with the message itself. What in the world is this code actually telling us? So, according to the official service manual, this is the technical definition. It's pointing to some kind of breakdown in communication somewhere in the front sensor system. Yeah, that's a bit of a mouthful, isn't it? Let's just cut through all that jargon. What this really means is that the system that helps you park, the one that detects objects in front of you, well, it's lost its ability to see. The sensors just aren't talking to the car's brain, and we need to figure out why.
Every good detective needs a map of the crime scene. For us, that means we need to understand the system and identify all the key players that are involved in this whole communication breakdown.
And here it is. This is our crime scene map. This wiring diagram shows us the entire path of communication. See, over on the right, you've got the brain of the whole operation, the ECU. That's the main computer. And it's connected in a chain to all the individual ultrasonic sensors lining the front bumper. We know the fault is somewhere along this network.
So this gives us our primary list of suspects. Is the problem with the brain, the computer itself? Or is it the eyes, one of the actual sensors? Or could it be the nervous system, that whole complex web of wires and connectors that links everything together? Okay, with our suspects all lined up, we can start the first phase of our investigation. We'll start with the simple stuff, right? The basic questions that can sometimes solve the whole case right away. The procedure here is really just common sense. First, you confirm the code is actually there. Then you try clearing it. Maybe it was just a temporary hiccup, a one-time glitch. If the code pops right back up, you move on to a physical inspection. You check all the plugs, make sure they're pushed in tight. You'd be surprised how often the solution is just a loose connection. But it's never that easy, is it? We've cleared the code, and boom, it comes right back. The connectors are all snug as a bug. This tells us one thing for sure. This isn't some simple glitch. We have a genuine fault on our hands, and it's time to dig deeper. Now it's time to get serious. We have to interrogate one of our main suspects, that nervous system. We need to test the integrity of every single wire in that circuit. And to do that, we need a special tool. This is the multimeter. I want you to think of it like a polygraph test for electronics. It can tell us if a wire has a good, solid connection, or if it's lying to us by touching something it shouldn't be.
So to get our answers, we perform two main tests. First up is a continuity test. Here we're looking for a really low resistance, under 1 ohm. That tells us the wire has a clear, clean pathway. The second test is a short to ground test. For this one, we want the opposite, a very high resistance. That proves the wire isn't frayed and touching the car's metal frame somewhere. So after painstakingly testing every single wire that connects the ECU to those sensors, the results are in. Every wire passes the lie detector test with flying colors. This means our nervous system, the whole harness and all the connectors, is not the culprit. We can cross it right off our list. Okay, so we've cleared the wiring, our nervous system. And since the brain, the ECU, is usually the least likely culprit in cases like this, well, that leaves just one group of suspects left to interrogate, the sensors themselves. The process of elimination has led us straight to this point. The communication breakdown isn't happening between the components, which means the fault must lie within one of them. The eyes are officially our prime suspects. So the final test is a classic detective lineup. You take a sensor that you know works perfectly and you swap it in, one by one, for each of the old sensors. You replace the first one, you clear the code, and you see if it comes back. If it does, nope, that wasn't it. You put the original back in and move on to the next one. And you just repeat that process until that error code finally disappears for good. And then, after swapping out that front left corner sensor, success. The code is cleared, and this time it stays cleared. The system is back online. The service manual gives us this beautifully simple conclusion. Case closed. You see, what this really shows is that by following a logical, step-by-step diagnostic procedure, a real detective's process, we were able to pinpoint the single faulty component in an entire complex system.
The car's blind spot has been fixed.
This case might be closed, but it really makes you think, doesn't it? Cars are basically becoming rolling supercomputers. The simple mechanical problems of yesterday are being replaced by these complex network and software issues. And that leaves us with a pretty big question. What new tools and what new kind of thinking are we going to need to decode the messages our cars send us tomorrow?